All right, let's get this started. Welcome. My name is Ryan Lowe, and I am building an Alexa skill. So I am a technical evangelist for Amazon Alexa. What that means is that my job, I get paid to talk about Amazon Alexa and ultimately encourage developers to build with Alexa, invent with Alexa, build new skills, and then help them along the way. And so part of that is I have to build skills myself so that I know exactly what developers are going through. And so that's what I've been doing. I've been live streaming this Monday, Wednesday, Friday for the past couple of weeks. And I'm just going to continue to build this skill. I have no idea how long this skill is going to take to actually complete. And that's kind of the fun. I have like the use case in my head, but I don't have it designed every single detail. So what am I building? I am building an Alexa skill that will actually hopefully help one of my own use cases. And that's what I always love to do is, or encourage people to do, is to build something that is relevant to them. Even if you're just playing around, having fun, which is kind of what I'm doing. I'm not expecting this to be the #1 skill for Alexa or even to make any money whatsoever. But I'm having fun and I'm learning, and hopefully this is inspiring and educating others to go do the same. So the use case I'm going after. So every Tuesday, I, with a co-host, Jeff Blankenberg, host developer office hours for Amazon Alexa. We do this live. We stream it to a number of different locations live, and we take questions. People can log onto Twitch or LinkedIn or Facebook and ask questions, and we'll answer them. But when we're done being live, the video gets archived in YouTube for anyone to see. So in YouTube, under the Alexa developers account, there's hours and hours and hours, probably hundreds of hours at this point, of old office hour video that anyone can go and watch. The trouble is, it's really hard to get to a particular answer. So we've answered tons and tons of questions, right? Probably thousands of questions. A lot of times answering the same question over and over again because they are important questions and new developers come on and they don't know the answer, and so they get asked again. So if someone wanted to go and find an answer from weeks ago, it would be very, very difficult. They'd have to just watch hours of footage hoping to find where someone else asked a question. So our idea was to index all of these videos and make them available for Alexa to search through. So I could go to one of my devices and say, show me from office hours where Jeff and Ryan were talking about APL, Alexa Presentation Language. And we could zoom to those points in time. If you had a show device, like one of these three back here that have a screen, we could just zoom to that part of the video and start playing it. You can say next, and it would zoom to the next search result. If you just had, if people had a device that didn't have a screen, and we could just do the audio recording of that. So that's eventually what I'm getting to, is an automatic way to pull down YouTube videos after they've been archived and then transcribe and index them into a searchable database, and then build the front end with Alexa to go and query that. So I've been working the last couple weeks all on the back end. I have this, again, like 10,000 foot, I have this in my head. A few months ago, I actually built like a really quick prototype just to make sure that these things would work, if I could connect these services. It was all manual, it was all done very, very quickly and hastily, but I wanted to prove out that this was possible. And my long-term goal would be maybe we can index all kinds of other Alexa videos and not only have a skill front end where people could talk to their devices, but also other front ends, like on our developer tools and website, you could get access to these questions. So what does this look like so far? Again, this is very much in progress. I'm building out this as I'm going and trying to figure out everything. So this is like the 10,000 foot high level view. Again, office hours are live. They get indexed and archived, they get archived in YouTube. And then we have to figure out some way to trigger once that happens. So in real time, we can pull down that video into Amazon S3, which is a storage service where we can store, past videos. Or we can store all kinds of objects, but we're going to store videos in there. And then ultimately, we want to get to a searching database. So my preferred one is Amazon OpenSearch here. It's Elasticsearch, I think, because Lucidchart, the tool I'm using, doesn't have OpenSearch yet as an icon. That's the ultimate goal, is to get it into that database so we can do full text searching of the transcript. But first we have to get the transcript, right? So Amazon AWS has a service called Amazon Transcribe, which allows you to take an incoming video and it will pull out the raw text. It'll pull out all the text, including the punctuation, available for you. And then there's another service called Amazon Comprehend, which will take that raw text and make a little bit more sense out of it. It'll help group it into different paragraphs and help identify speakers and tags and themes and keywords and so on. So it gives you a little bit of comprehension, hence the name, on top of just like a raw text stream. But before we do that, what I found out in early phase when I was testing this out is that the format that YouTube gives you when you go to download the video is a different format. It's an MP4, but it's a different format than what Amazon Transcribe needs. So there's another AWS service called Media Convert, which is what we were working on Monday. We were working on getting Media Convert to work, to basically take our incoming video and transform it into just another MP4 format. This is where I got a little lost. I have not used I've used Media Convert in the console where I said, here's a file, go convert it over to a different format. But I've never used the APIs. I learned a lot, especially I haven't set it up in Cloudformation. So I was fumbling around in Cloudformation, testing this, trying to get it to work. Then I figured out how to get the APIs to work and got all my Lambda permissions correctly. And I fumbled around a lot on Monday, but that's how I work. I think that's how all solution architects work, is just try something, look at the error messages, then just keep working on it until you figured it out. Media Convert especially is a huge service. The APIs are extremely verbose. It does apparently a million different things, and I only wanted to do one particular thing. And so at the end of Monday, I was able to kick off a process where I took an already downloaded file from YouTube and ran it through Media Convert, and it did actually produce an output file. I have not verified yet, and we'll do that here really soon, that output file can be used by Amazon Transcribe. It should, because I got this to work again a few months ago, but I haven't actually automated it. And speaking of automating it, the other thing I'm using is Amazon or AWS step functions. So I built a state machine, which is inside step functions, to kind of orchestrate this whole process. So all of these are long-running processes. Like Media Convert might take 10 minutes, Transcribe might take 10 minutes. Like this whole process might take half hour to an hour, again, because I'm looking at full hour-long videos. And I want this to be a stateless as possible, or serverless, I should say, serverless as possible solution. So Elasticsearch and OpenSearch, they're not serverless. Unfortunately, we don't have an open source solution yet. I would imagine there's 20 other databases. I would be surprised if another one isn't coming. I might challenge myself a little bit later on to determine if there is a different database we can use that is serverless, like DynamoDB, but it's not really good for full text searching. And I want to be able to pull out like any sort of text, not just like prominent tags from different paragraphs of text. So right now I'm gonna use OpenSearch, and we haven't gotten to that part yet. I think that's going to be coming soon. But today what we're going to be working on is looking at the step function that I executed at the end of Monday. See what happened. I know it's going to fail. I know it's going to fail because Amazon Transcribe is not set up to take in the input that is the output from Media Convert. We'll solve that. And then I think what I'm going to do is write a Lambda function to go pull down a YouTube video and store that in S3. I was able to find everything else I've been writing in Python. This particular Lambda, I think I'm going to write in Node because I know how to do streams in Node. Python is still somewhat new to me, and I know how to do this in Node, and I found a great blog. I borrow from blogs and other people's hard work all the time. I think it's what all developers do and should do if they don't. And so we're going to do that. But I think this function I'm going to write in Node. The rest of them are going to be Python. And that's fine. We can mix and match. If I wanted to write a Java Lambda and mix it in here, we totally could, although I do not want to. So then at some point we have to figure out how to trigger the YouTube videos over. And I was reading up on this. I didn't want to live stream me reading documentation, but I did I did find some documentation on how you can use Google's, what is it? They call it like pub sub hub sub thing. Anyway, they have a tool which will notify a web endpoint when a new video is available. And so what that tells me is that this trigger is totally doable, but we're going to need to put an API in front of it. And luckily we have API Gateway, which is a great way to handle this incoming request. So then this trigger then becomes a Google trigger that calls an API Gateway. So when we get to that, I'll update this diagram, but we'll see how far we get today. I am reasonably optimistic that we'll get to at least download the videos. So then our orchestration will be, the incoming signal will be a YouTube video URL. Then it'll kick off a series of Lambda functions. The first one will be downloading the Lambda, sticking it in S3, and then handing that over to Media Convert to convert it over, and so on. And so what does that state machine look like right now? So this is what it looks like. Let me zoom in on this because I think it's growing and is actually getting very interesting in my mind. So let me zoom in more. Here we go. So we start with the YouTube convert. So this is actually a Lambda function. Again, this is an AWS service that I use for orchestration. I find it very, very handy because you can call Lambda functions and other things. So we're going to start this state machine with a Lambda function that's going to take an incoming video that's already in S3 and run it through Media Convert. So the way I designed this is that I have a Lambda function that all it does is call the Media Convert API to create a job, and then it ends. So this Lambda function runs in a few milliseconds, which means my cost is almost negligible to kick off a Media Convert process. So then what I do is I have this wait state, which is not a Lambda function. It's actually a predefined state machine state, which just says wait 30 seconds. So it waits 30 seconds and then calls another Lambda function and check on the status. And then I do a decision point, which is another built-in state. If it's finished, then great, go back to, or actually we want to move on to transcribe start. We want to actually transcribe the video now. If it's not finished, then what we do is we go back to wait. And if this errored out, then we have a particular error step, so I'm able to track this error step. And the cool thing is, there's built-in states for things like sending notifications on simple notification service. So like when an error happens, I could publish a message which would end up triggering a text message or something like that to tell me like, hey, something failed, which would be great once I start operationalizing this and running it every week. I could just assume it's working unless I get a text message that says it's failed. So I may add that in at the end if I remember. If not, it's something you can do. Okay, so what I'm really excited about is that the Media Convert actually works. We ran into a bunch of issues last time with permissions and assigning roles and passing roles and Media Convert. And Media Convert stands up an endpoint in your account, which you have to then call, which is all done via the API, but you have to go fetch what the endpoint is. And so a bunch of that stuff, which is all brand new to me. I haven't used this service before, so that was kind of fun to work through. But I got it to work. But the big thing is, when we were looking at the API definition of Media Convert, I wasn't sure where to find the output file in this big, long response. And what I mean by that is if I go to, by the way, I do have a GitHub repo where I'm posting all this. I try to update it every time I'm done streaming coding so people can follow along. And because I'm using a service application model, which sits on top of Cloudformation, anyone can take this and deploy it in their own account. It's really kind of cool. So anyone can just follow along and run the exact same code. But what I was getting to was, if I look at the documentation for, this is the transcribe service. So I want to go to, this is Botto 3 documentation, which is the Python SDK that I'm using. If I look at the documentation for Media Convert, we have a ton of services now. There's one API that I call create job, which will go and create it. And then the other API that I call, I accidentally clicked on something. The other API that I call is get job here. And that's get queue because I accidentally clicked the wrong thing. Get job. This page is humongous, so my browser like jumps around when it's trying to actually like view this page because these API definitions are huge. So get job is simple. You pass it the job ID that you get when you create the job, and it gives you the response. The response is huge. And so I'm lazy. I could have just, I could have read through all these, the response payload, and I could have looked at all the different attributes and read through the documentation. And I started to do that. I was trying to find like, where is the output location? What's it even called? Is it output? Is it destination? Where is this file being located? So I said, never mind. What I'm going to do, and the reason, the big reason I need this. So this is my code on my local machine. If I go over to media convert status, this is that API. So here I'm saying get job, no big deal. And then I'm logging the response. But the big thing is I need to be able to get the location of where media convert put the file so that when the next function calls transcribe start can pick up that file and process it. So I need to know what the file name is, or I know where it's being saved because I'm saying, here's my S3 bucket, go save the file there. But I need to know like what is the prefix, what is the key, what's the file name and folder structure. And so what I did was I just said, you know what, I'm not going to go through documentation. I'm just going to run this. And then because I'm logging the response, I can dig through my CloudWatch logs and figure out where the S3 file is. Hopefully that's my goal. So let's start there. Let me go back to my state machine where this is the last time it ran. And so it failed on transcribe start. I totally expected that. And if we look at the exception here, yeah, it just failed. Actually, I'm not even passing the content type. So that's another thing I need to figure out is how to pass content types. So let me put a note here so I can figure that out. Because that seems like that's going to be key. And I want to keep my template, my YAML template, Cloudformation YAML template open here. Okay. So now, in order for transcribe to work, and I guess I should explain this a little bit, the way state machines can do a lot of really cool things with parameter passing. I'm using like the very basic of it, which is I pass into the state machine an input, right? And that input gets passed to the first Lambda function. Then the result of that Lambda function gets passed to the next Lambda function, and so on. So my status function here, where it gets the status of my media convert job, has to pass to the transcribe start all the detail. And so you'll see things where like this method here is also just doing like a pass through of like I'm passing through the incoming event to the output, just so that the Lambda functions down the chain in the state machine have access to that too. There's better ways of doing that, but this is kind of like my my poor man's way of doing this because I know this makes sense to me. I can track the data flowing through. But this is how I work. So what I'm going to do, so this is where I'm going to start. So I'm going to look at my last time this executed, my get status of the media convert job. And I'm going to go to the CloudWatch logs. And hopefully what becomes quickly apparent is that I can find the S3 bucket of the output. And here, because I have debug, logging level debug, it will actually log quite a bit of detail for me. But what I'm looking for is this line here where I am logging the response. And so this is the last, my last logging statement where I'm saying log the return value just so I have it. So this is the response of media convert. And so what I'm hoping is that in here, and this is kind of my trick, I just take this out and let's just paste this into my editor. So here, what I'm again, what I'm doing is just I'm logging debug the actual response object. I really need to update this because I have a much better way of logging now where what I'll do is I'll actually do a JSON load. So I'll convert this object into a JSON object and log that JSON object because this looks like JSON. It's almost JSON, but it's not actually JSON. And so what I can do is replace all the single quotes with double quotes. And then this is my trick that I do. And then I come over to do like a JSON pretty print. And paste this in here and say make pretty. And then there's weird stuff in here. This is why if I were to do a full JSON parse, this wouldn't happen. So I'm just going to remove some of this stuff. I don't care about the date times anyway, so let's just get rid of that. So what I'm looking for is the S3. I'm looking for like the key structure to get me from the response to get me to the output. And there must be another datetime function in here. There it is, created at. Make pretty. Okay, perfect. So now if I take this and paste this back into, actually put it here. Don't save. Okay, so I'm trying to fill out this part here so I can pass to my other the transcribe start, like where the file is, right? And that's the destination folder. So, okay, unprocessed is the file I passed into it. Process is the folder I said put it in. Please tell me it actually will give me the specific location. It does not. Interesting. I have a workaround for this, or I have another idea for this, but I was hoping it would give me the exact. Okay, so let me show you this. If I go into Cloudformation, this is the Cloudformation stack that I'm deploying using the Service Application Model Framework. But the nice thing is if you come in here, you can get access to all your resources. So I'm going to go into S3, and when this media convert ran, it put the result into the processed function here. This is the one I uploaded manually. So this is from when I was testing later stages. As you can see by the timestamp, it's the 13th, but the 26th, I ran it again this morning just to make sure it was working. So the 26th, this is the output file. And if you look, this output file name is the same as the name of the input file. So what Media Convert's doing is it's saving it, it's taking this file in the unprocessed folder and putting the same file name in the process folder. And I was looking at the Media Convert documentation, and I was worried that this is what was happening. It's not a huge deal. I noticed that in the, like when we set up the job template, we could also modify the name. So we could do things like out and, like -out and change the formatting and things. The key thing here is that like we should just be able to take this and pass it, and we know it's going to be the same name, so that's fine. That's great. We know what to tell. We know what to tell transcribe start where the file is. So we can just take this incoming key, which is, if I go back to my state machine, is this right here. So instead of unprocessed, we want processed as the key. So what I'm going to do is output prefix equals, we'll say process. Oh, I'm a terrible speller. And then what we're going to do is we're going to and again, my brain, I work with so many different languages that my brain crosses these all because I'm not actually really good at many of them. I just need more practice. So let me take the event incoming key and split it. And then what we want is we want the first index. So here, the incoming key is unprocessed / the name of the...
Sorry, I'm not sure about that.
I triggered my Alexa. And I don't call it Alexa, so it's interesting that it heard the wake word. Okay, so the incoming key here is unprocessed / the file name. So really what I want to do is take the file name and join it with processed. I could probably also just take off the first 2 characters of the string. There's a million different ways I could do this, but this is what I'm going to do. And then the nice thing is I will actually get, I'm logging this return value so I can verify this is the right return value. The content type, so the content type I was passing into the state machine, but I don't want to do that anymore. And what I was passing into the state machine for transcribe start to work was this. And this I pulled directly from the blog post that I've been following, which used, so I'm following this blog post, or I got inspired by the blog post. I started with copying and pasting a lot of this code. I've then now been modifying it and making it my own for my own use case. They're processing RSS feeds of podcasts, which is really cool. My use case is a little bit differently, so I've been modifying it as I need to, and this might be a point where we need to modify it. So transcribe start, let me actually pull that up. Where is transcribe start? So transcribe start API here needs the media type, and the media type it needs is actually just MP4. That's all it's looking for. They're doing like lookups in different media formats. I left a lot of this code in there until I knew that we could remove it. So what I want to do is look to see if this output response from media convert can give me the details I need. I think I just need to specify MP4 and just be done with it. And in fact, I'm always going to be working with these. So I'm just going to hard code this as MP4 and be done for the day. So what this allows me to do, okay, so this again on the right here is my media convert status call. The output of this is going to be directly passed to transcribe start. So this return value is going to be the input event to this function. So now what we need to do is modify this, which was working originally for, originally this was working as just the very start of the state machine when I was working on this a week ago. But now it needs to conform to the output of this. So what do I need to change? First of all, let's get rid of all this content type conversion stuff. We're just going to get rid of all that. Okay, so content type is just going to be that. And let's make sure content type isn't used anywhere else. And I'm actually going to rename this variable. I don't like having different variable names. So let's look for media type. Okay, so that's the first step. The second step is now we need to figure out the bucket in the location. So the bucket is going to be our standard bucket that we're using. So I already passing it in here. So what I mean by that is if I come down to my SAML definition of transcribe start, as an environment variable, I'm passing in these 3 values. So a custom vocabulary, which we set up a long time ago, and then the S3 bucket. And this S3 bucket's where we're doing everything. It's an S3 bucket that's created by this Cloudformation, so it's a custom bucket for this solution. But here I'm calling it output bucket. It's no longer the output bucket. It's just called bucket in my mind, because it's going to be the input and output bucket. So let's find everywhere we had output bucket. Oops. And let's just call this bucket. Okay. The other thing is, so now we have, so that means we can get rid of this bucket. So this was the original bucket, the input bucket that was being passed into the state machine. But now we just know it's going to be in our bucket. So let's just get rid of that. And then the key is actually going to be from the event output prefix. So the bucket's already defined. We're the same bucket everywhere, so we don't need to actually grab that and pass that around as return values. Here, I'm going to change I'm going to change key to output prefix. I think it's just is a little more consistent that way. And make sure there's no more keys anywhere else. Cool. Okay. So now this is my return value. And again, the output of this is going to be passed directly to the next function in line. The next function is going to check on the status of the transcriptions. Again, it's another long-running process. So this function kicks it off. The next function is going to then check on the status. So the big important thing is we pass the job name back from the responsive start transcription job. And that's fine. But I also like to pass through variables. So as an example, output prefix was being returned by the media convert status, getting passed to transcribe start here. But if I don't explicitly put that as a return value, then my next all the other functions along the chain won't get that. And so I just need to make sure that, like, is that fine? Am I fine by that? Am I fine by saying transcribe start won't get that? And it is actually fine, because the only function that needs that is to kick off the transcription start. Transcribe status is going to have other outputs from transcribe start that it can go and run with. So I think we're okay by not needing to modify any of that. And same with like content type. I am passing that through. So let's just continue to pass it through. Again, there's better ways of doing this where you can use like a JSON syntax to like reroute events and parameters and stuff inside just the state machine. It's really, really cool. I just get really confused when I start to work with it. So I kind of just ignore it and just make like the simple way of doing it. That's kind of how I work with all these services. All these services do an amazing amount of things. I've figured out like my one trick to do with each of these services, and that's what I'm stuck with in my head, unless I need to go learn more, which sometimes I do. Okay. So now transcribe start should work. It should take the output and fine. So let's deploy this. So we can deploy this using the serverless application model. And this takes a few minutes. So again, what is this doing? First, let me take a drink of my coffee. It's still pretty early for me. I'm just making sure this is going to kick off fine. So I could, I'm using serverless application model, which sits on top of Cloudformation. I could use Cloudformation directly, but serverless application model, SAM, is really, really convenient, because what it will do is precompile all my Lambda functions for me. And it has a bunch of other shortcuts that then get inside my template. It will then get transformed into real Cloudformation. And we're going to use this again here really soon when we set up an API gateway. We're going to use the SAM syntax to do that, which will just make our lives a lot easier. You can do it in straight Cloudformation. But what it's doing right now is it's using a Docker container to basically package up all my Lambda functions. So these Lambda functions, like we're looking at transcribe start here, they have requirements, dependencies, and these dependencies will get packaged up by SAM into a zip file, and then that zip file gets uploaded to Amazon S3. Really, really handy, kind of a shortcut way of getting to the end result, which is a Lambda function has all the dependencies. A lot of times, what I've done in the past, especially when working on AWS solutions in the past, I would try to write my Lambda functions with 0 dependencies, so I could actually specify the Lambda source code directly in my Cloudformation template. This is also really handy. Like what I'm talking about here is like instead of passing in like the location of where to get the code, I would actually just paste the code into the YAML file. It made for really concise CloudFormation templates. And what I liked is you didn't have to like compile or package anything up, but it really limits on what you can actually do because you have no ability to go get dependencies. So SAM handles dependencies. All right. So then what it's done is it's said, okay, I've created a change set. I've looked at CloudFormation, what you've already deployed. Here's the differences between what you've deployed already and what was changed. Do you want to deploy this? I'm going to say yes. And hopefully this gets deployed. This part's usually pretty quick. The first part takes a little bit of time because that's to compile each of the Lambda functions. And as this solution gets bigger with more Lambda functions, it takes longer to go and do that. So it should be updating. If I go over to CloudFormation, we can see that it did just update. I can look at the events. These are the exact same events that show up on the CLI, so I can just see everything that's happening. But my state machine has been updated. So let's try a new execution. So here now, I'm going to get rid of content type because we've determined that we don't need to actually specify this as an incoming parameter. It's always going to be an MP4. So this is my media location. Eventually, my state machine is going to get updated. Let me actually start this. Eventually, my state machine is going to get updated. So the very first step is going to be take an incoming YouTube URL and download it, save it to S3, and then that new Lambda function that we have yet to write will then pass into YouTube convert that structure and so on. So we can go down the chain. So we kicked off a new whole process. It's creating the media convert job. The cool thing is I can go over to like the media convert console, which is another AWS service. And I can actually see that the job kicked off here. Here, you can see I ran, just to make sure before I started streaming, I made sure this was still all working so that we were all good. So I ran a job earlier this morning. This is the job that's running now. This job took 12 minutes to complete, to convert from one file format to another file format. And so I think while this is working, my hope is it actually goes through the entire process, and it did not. It failed. Okay, so what failed? Key error, media convert endpoint. Interesting. Okay. I didn't even change that. I didn't change anything with that. But yet it failed. So on line 27, there was a key error. You know what? I wonder. Let me open up media convert start over here. So it's saying this was not found in the key. So what was the input to this? The input to, okay. This is really interesting. How did this work previously? So in between, when I finished the stream on Monday, I did something sneaky. So I changed the code, but I wasn't going to talk about it because it's a pretty minor thing. So this is what I did. So when we were working with media convert on Monday, one of the things that we noticed is that we needed to get this endpoint. So when you start using media convert in your account, it will create an API endpoint that's unique to your account. And it appears you can create multiple API endpoints. I'm sure there's all kinds of reasons for that media convert does, probably to manage jobs and queues and things like that. But you need that when you create a job. You need that endpoint in the media convert client so you can create the job correctly. So here I'm specifying the endpoint, so media convert knows which endpoint to use. It doesn't just go to the default one. You have to actually specify it. So what I did is I created two clients. The first one to get me the endpoint. So I'm basically making two two API calls here. First to get the endpoint, and then to use that endpoint to create a job. And so in my status one, I did the exact same thing. I said, okay, first call I need to do is go get the endpoint, and then use that to go get the status. The issue I realize is that this returns an array of endpoints, and if this array ever grows to more than one or gets resorted or something like that, I may not be guaranteed to have the same endpoint using this logic here. So what I decided was well, I have the endpoint. Why don't I just pass that endpoint? It's just a string as my return value here, so that when my status function gets executed on the right, it just is using the same endpoint because I can get that from the event. What I neglected to do, and this is exact example of what I was talking about, is part of this. So the return value of this function is going to be, since we're in a loop waiting on this to finish, the return value of this function is going to be the input next time it runs. And so what I didn't do was give this function its own input. So now the way this works, this function here on the left will execute, kick off the job. It'll return back this media convert endpoint. The status function method will run. It gets the media convert endpoint from the incoming event from the start method, and it's fine. And now what I'm doing is I'm saying, okay, but when you run again status method, give yourself the media convert endpoint so it can run again. And so that's what I'm doing here. What's bothering me now is that there seems to be, why are these miscolored? Am I missing something? What am I missing? Oh, that's a comma. That should be, there we go. Okay. So again, every time this runs, it has to make sure it has the same input every single time. So I'm passing through the input to the output so that when it runs again, it has the same input. I hope that actually makes sense to anybody. It makes sense to me. So yeah, the two inputs it needs, I'm passing. Okay, let me just recompile this and deploy it. And away we go. This might take a little bit of time. Again, there's better ways of doing this, but this makes sense to me. So this is a pretty small change. All I did was change this here. I could have gone into my Lambda function that's already deployed in the cloud and made that change. But I like to, one of the things that's really nice about using SAM is it's very consistent. You get to control and code your infrastructure. So I always like to change in code and then publish up. Every once in a while, if I'm doing like really small troubleshooting, I may just update the Lambda function in line up in the cloud and rerun it and see what happens. But if I do that too much, then I get out of sync and bad things can happen. So I try not to do that. Unless it's like a really tiny thing to do. So this is running. I think I want to start talking about the download method. And I have here we go. So while it's recompiling and deploying and all that, like any good developer, instead of just like trying to code and figure out myself, I just did Google searches to say, what's the best way to achieve this problem? So the next problem I haven't had to solve yet, which is how do I, in Lambda, download a YouTube video and store the video in an S3 bucket? Up till now, I've downloaded them manually onto my local machine and then uploaded them to S3. And so what I haven't done, I haven't actually solved this problem yet. I know it's solvable. I just haven't actually written the code to do it. And so what I wanted to do is do a quick Google search. And what I found was this blog post, which I haven't actually tried yet, but it seems from my past experience do what I want to do. So what I really like about this is it's written in Node. And again, okay, so I'm going to deploy this. I'm going to switch back and forth. I'm sure I can do this in Python, but I know how to do this. I've done this in Node. This code looks familiar to me, so I want to use it. And what's familiar about it is the ability to stream. So when you're downloading these files, so this YouTube video, they're usually about 1 gig in size for an hour. I don't know if that's always true, but the files I've been working with have been. And when you're working with Lambda, there's only a few different ways to process these big, large files. And I'm going to pause there, and I'm going to re-kick off my state machine now that it deployed. Okay, so what do I mean by this? So I'll leave this window open to make sure it's working while I'm talking about it. So you have this 1 gig file. If you're running a server, like an EC2 instance or a server, you can just download it to the server and then upload it to S3. No big deal. And you could probably even get away doing that in memory. You could download it not even to disk, which when you have a server, you have just endless supplies of hard disk around. Certainly, you have 1 gigabyte, you could probably get pretty easy. Disk space is super cheap. So you could just download the disk, or you could probably download it to memory and then upload it there. In Lambda, it's a different world. Lambda, you're charged by how long the function executes, but also the size of memory. So you kind of want to be careful. Like, you could design this in a way where you could pull it down to memory. Like, you could make a really large Lambda function, but you're going to be wasting money by doing that. And so what I like to do, and I've done this with downloading really large objects from one S3 bucket to another S3 bucket, is we'll just create a stream. In Node, you can create a stream to say, let me download a stream from one S3 bucket, reroute the stream to a writer in another S3 bucket, and then you're just passing it through without ever actually storing it locally. And that's what this blog post is doing, and I love it. So they're using a stream. They're using a library called YouTube DL. And then they're saying, like, I want to download this stream, but I want to pipe it as a pass-through to an S3 upload. And this is great. This is exactly what I want to do. It's really simple, very concise. That's what I like. This method may still take a while to execute. So I really prefer to create methods or Lambda functions that will execute in like a few milliseconds, like transcribe start or media convert start. I say kick off the job, and then I use state machine to wait. I can't do that here because it has to actually process the file. So this is kind of where we're at. So let me start creating this function while we wait on this, because again, this state machine, if it runs and completes, it might take up to a half an hour. So I'm not going to sit here and wait. I also don't want to end the stream yet because I think we can still make some progress. So let me start making progress by creating a new function. So here I'm going back to my SAML template. It's very similar to Cloudformation template. And I am going to create a new Lambda function, YouTube download. Let's just copy and paste a lot of this and update it. Okay, so the code URI is going to be YouTube download. So let me create a new folder where this is going to be. And now this is going to be a little bit different. So we're not going to, we want to create a node Lambda function. And so this is going to be a little bit different. So instead of runtime, I need to go figure out what the latest runtimes are. I don't know what the latest Lambda runtime is. So let me just figure that out real quick. I'm just going to do this by just doing, so I'm going to create a dummy Node.js runtime. So let me just create that. So then this helps me figure out what this needs to be. And actually, probably the easiest way would be Lambda AWS runtime. Yeah, this would have been the quickest way to do it. This is what I want. So 14x is the latest. That's what I was able to create here. Yeah, runtime 14x. That's the latest. So we'll specify that. Handler, it's always like the index file. So we definitely need the S3 bucket. We don't need these two things. In our policies, it needs to have access to the S3 bucket. So I'm going to get this policy. So now I've defined in Cloudformation my function. And now what I'm going to do is come over here and specify my index.js file. And what I need to also get is, so basically I'm recreating this structure here, right? So the next thing I need to do, hold on, let me go back to step function. I'm just going to refresh that to make sure it is actually working. Okay, cool. Sorry. Something distracted me. So now what we need to do is do like set up a package, an npm for node dependencies. That's where I was going. Sorry. So let me just do an npm init. I think this is the right way to do it. I haven't done this in a while with SAM framework. So, but let's just do it this way. Just that's fine. Yeah. Okay. Fine. Okay. So great. Now I have my package file. Now what I want us to do is say I have a dependency. My dependency is YouTube DL. Let's just verify that this is an npm package, and we're all good there. This package has been deprecated. Oh no. My blog post that I really liked must be out of date. So let's look at this one. So we should use the latest greatest, right? Okay, so require okay. So well, I'm hoping that the API syntax is kind of similar. And just because I'm that lazy, S3, and let's see if someone's already solved this, so I don't have to, right? Okay, so they're, see, they're using that version too. Oh, because it's 3 years ago. That's why. This is how I learn. YouTube DL exe. I found that. That's this. Oh crap. Node wrapper for that. Okay, I just want to make sure that I find. A good example of this to make sure that I get the latest greatest. That is definitely not helpful. YouTube DL. Use. Okay, I'm gonna actually have to read here. Darn. Let's see how these APIs are different now. Maybe we want to go to the actual GitHub repository. Usually I better, for some reason I can read the documentation better here. Okay. So here, it looks like they're keeping things pretty similar, in fact. So the video pipe, yeah, I think I went to the wrong one. It hasn't changed because I clicked on the wrong one. Okay, U2DL. This is the new one. Okay. Alternatively, okay, subprocess execute. Interesting. Is this only... Now I want to look. So this is a node wrapper of this other library. What I'm confused about. Where is the stream? Sorry, guys. I'm going in circles here. So this is promise and stream interface support. Okay. Output. Download. Available though, download on build time. You specify your own path. See environments. Okay. This is really interesting. Where to put the binary file? See, I don't want to put the... I think for right now, I'm just going to follow this this blog post. I need to resolve this other information, but for right now, let's just let's just use this deprecated one. That's terrible, isn't it? You know, I probably didn't have to do an npm install. I probably just need to add YouTube DL to my package list. Yeah, because this will download the whole node modules and all dependencies, and my package manager should do that for me. But anyway, that's fine. Okay, so go back to my state machine. That is still media converting, which is totally fine. Okay, so here's my Lambda function. Goodness. Okay. Now, we want to require stream, which should be by default. We should require the YouTube DL. I like putting all my requires at the very, very top. And of course, the AWS require for the SDK. Okay, so this actually needs to be done inside the handler. So now we have our handler. So here we're going to do our work. Let me fix these indents. So this is where we're going to do, kind of all of our work is inside the handler. I'm just doing one quick search. I'm using a different screen. Sorry. I want to cheat and use the same logging that I always use kind of for everything. Oh no, is this all done? Okay, hold on. Okay, I'll do it on this screen. I just feel like I'm getting too many screens open. So what I'm doing here is AWS samples. That's AWS samples. Digital. Okay, sorry. So what I'm doing now is I'm going to one of my previous libraries and grabbing like how I did Lambda or logging. I'm trying to get to logging. So this is other code that I've written, and I don't like the way that logging's done. Let me go to Cloudformation. So these are other Cloudformation scripts that I've written a long time ago. You can see here, like I'm actually doing a lot of the inline code editing that I was talking about earlier. That one happens to be Python. Let's see if we can get to one. I started doing a lot of Python. I'm trying to get better at Python, but I'm still not great at it. This is still Python. Are you kidding me? Okay. I'm just gonna. Come on. One of these connect as a channel. Come on. So this whole library is Cloudformation templates that I've built for Amazon Pinpoint, where I used to be a specialist SA. Did I only do Python in this whole entire repository? I'm not the only author here, so I'm hoping that somebody else. Please save me. My S3 data lake solution. Dang, I'm still not doing like the type of logging that I was looking for. That's all right. Okay, so we'll just do console.log event and just log the incoming event. I have to remember semicolons. Goodness. Okay, so YouTube URL. So the incoming event here I'm expecting is YouTube URL. The outcoming event, what I'm expecting here is going to be what my media convert start requires, right? Yes. So here, this event here, actually, I can go to my state machine where it's even better articulated. Look, we got transcribe start worked. Transcribe status is working. This is awesome. Okay, so execution input. I'm expecting this structure as the output. Perfect. Perfect. Where was I going? No, it's going here. Okay. So bucket. So we can do const bucket equals Oh my goodness. My brain is totally freezing up. How do we get environment variables in JSON or in Node.js? Oh my gosh. I've been doing too much. Now I'm completely useless in like all languages. I can't remember like simple like process.env. Oh my goodness. Today's a long day. I just started. Okay, so there. Now I have my bucket, so I can pass that back as the return value bucket. Key, so we need to figure this out. So const key is going to be, this is the S3 key. So unprocessed slash, we need a name. .mp4. So I need to figure out how to get to that. So what I need to also figure out, what I haven't figured out exactly is what is the incoming. So we're going to use Google's Pub Sub Hub to post to us when a new YouTube video is available. That looks like I've been Googling this and trying to figure this out, and I'm getting pretty close to like what the solution is going to look like. And it should give us like all the details. So it should give us the YouTube URI, and then also other information like the channel title, the video title. So we're going to have to take this this title and convert it over to something that is like string safe or S3 key safe. So I need to figure that out. For right now, I'm just going to call it name.mp4. But I need to be able to pull that out and pass that to, actually, let's just do it like that. We can just do event dot YouTube video name. So let's just pass this in as an event because we'll have another Lambda function that triggers this one. And I'll just do .mp4. So now we have our key going out. That's fantastic. But now we actually do the downloading. So I'm going to minimize this window again because we're not going to get to that stuff today. Okay, so let's go back to this blog sample code. Okay, so now we do the interesting part. So, okay, we've gotten our YouTube URL. We are piping it to a pass-through. The pass-through, I'm going to move that down, but first let me do this. Let me paste in this code here. We should probably create the pass-through here. Okay, so we're creating a pass-through stream, downloading the YouTube video from the event source, passing it through to our pass-through. Now we have to upload that back up. So here, I'm just going to be consistent. Bucket key is going to be the key, but we haven't actually defined that yet, so we should move this up here. And body is a pass-through, and then all that looks great. Fantastic, but we probably need to wrap this into a promise. Yes. Oh man, I haven't written Node in a while. I got all confident and it's like I can write this in Node, no big deal. But then I didn't. Okay, so let's look at the Node.js documentation. Because I'm wondering if there is, you know what? I just need to do this. Const p equals new promise. And then return p.resolve. Oh my gosh, I hope this is correct. Actually, no. I do that and I do return p. Oh my gosh, is this right? That's not what I meant to click on. There's like 100 different ways to do this. This is gonna be one of those. I'm just gonna deploy it and see how broken everything is. The more important thing is this working? And it totally. I just want to make sure the transcribe is able to finish successfully. So what was passed to transcribe? Let's look at that. Step input. Complete output prefix. Yeah, everything's looking great. Okay, so now, we have our YouTube download stub function. We should be able to start uploading soon. So now, I'm not going to add this to this. So I will add this to the state machine. I'm not going to do that today. I'll probably end up doing that next time on Friday. I kind of just want to see if this will build correctly. Because again, everything else here is Python. So now I have my first node. And maybe I should just rewrite this and find a Python updated library and just do everything in Python. I have to figure some stuff out before I stream on Friday, apparently. Let's see. So that's running. I'm having an off day, and I think that's okay. I'm not always the most efficient, and my brain is just not ready to go. But if this state machine works, then that is good success. If this deploys and I'm able to push up my new node function to the cloud, that is success. I'm going to delete this dummy function that I created manually. I want to, again, I don't like having my local out of sync with what's going on. So hopefully this finishes soon. Hopefully this finishes it all. I'm half expecting Sam to not like this. Yeah, there's vulnerabilities in that package. Yeah, I think... okay, I'm going to need to look at that. Because I definitely don't want to deploy something that has 9 vulnerabilities, 4 of them being high. So I may have to have a new approach to downloading YouTube videos, which is fine. But let's just see if I'm getting the logic correct. So that'll be research I'll do before next time, is figure out how do I want to download these YouTube videos. So maybe I don't want this to. All I did was a build. I didn't do a deploy on this, and our whole state machine worked great. Awesome. So at least I know if I have a downloaded video unprocessed in S3, this whole chain will work. And so what is this doing again? This is taking a YouTube video that's unprocessed, that's been downloaded directly from YouTube, and run it through Media Convert, which will convert it over to a different MP4 format, which then can be used by Amazon Transcribe. Amazon Transcribe will go through the whole video, pull out all of the text, and we pass it over to Amazon Comprehend. And the output of Amazon Comprehend is a bunch of JSON files loaded into Amazon S3 that we can then put into our search database. And over here, it seems to be working. So what it's doing now is it's downloading a new Docker image. So I've only ever built Python functions in SAM. So now what it's doing is it's downloading a Docker image for Node and pulling that down so that it's able to compile the Node function I just wrote. But again, I think those dependencies are really starting to bother me. I don't like having that many bad dependencies. So we'll fix that. I'll figure out a new approach. Maybe I'll even test it before I fumble around trying to write really bad Node code and promises. But let's just see what happens here. And what is the format? Because maybe I can manually trigger this. I'm just curious now, even though I'm probably going to rewrite this, but I worked on it, so let's figure this out. What does the URL need to look like? I'm curious if it has a certain requirement. So now it's building. Oops. Oh, okay. It's just looking for something like that. So let's go to YouTube then. What was it looking for? I just copy and paste it. It's looking for that URL, like watch-v. And look, we got that. This is office hours from January 4th. See, look, there's me in office hours. And that's Jeff. That's my buddy Jeff. Okay, so what we can do is if this deploys correctly, I can pass this in. And if it deploys and packages this node file correctly, then I can trigger this in Lambda. I can just trigger, it's not part of the state machine, but I can call the Lambda function directly and just see if it will download and see how far we get. So build successful. So now we can do a, let's do it this way, SAM deploy. And we can try this before the end of the day. That's so cool. This worked. I'm very happy about that. Change sets being created. Oh, we encountered an error. Number of errors found. Is it policy index 0? Policy is not valid. Didn't like this. Oh, I forgot to. That is silly of me. So I just had a typo. I forgot the statement in my policies. So again, what this is, so up here in the top of my Cloudformation template, I have resources. And again, this is actually a SAM template. So it'll basically do a transform on this to get to Cloudformation template. But in the SAM template, I'm able to specify Cloudformation syntax. So here I have Cloudformation objects, resources being defined, including like the media convert template, all that stuff. And then here I have Lambda functions. And this is SAM syntax. This is not Cloudformation syntax. Because what you can do in SAM is specify the code URI, and it'll go and package up that and create all the dependencies and package up the Lambda code. You can specify policies. So instead of like creating a whole different role, IAM role as a resource, and then linking to it, you just create the policies here, and then SAM will create the role for you. It'll create, so this will actually create two different resources. And then later, when we start talking about API gateway, which will be the incoming like trigger, the webhook that we get from Google, we can specify like an event trigger for this Lambda and just specify that here, and it will go and create the API and everything. And so it does the same thing Cloudformation does. In fact, it will transform this document into real Cloudformation, but it allows me to express the architecture with way less code, way less resources, and let Sam handle that. It's really, really, really cool. The downside is, like if I can check all this in and you can run it, but in order for you to run it, you have to get the SAM CLI installed on your local machine. You have to get Docker installed on the local machine. And then you have to pre-compile everything in order to get to a point where you can deploy it. So a little bit more steps for people. Like when I built AWS solutions in the past, if you like AWS, if you just Google AWS solutions, you'll find like these like really awesome collection of solutions that I was able to contribute to. They just give you a CloudFormation template and say deploy this, and you can just go. Like you don't even have to do anything on your local machine. You can just paste it into your account and go. And the way they get around that is like there's a bunch of build scripts that deploy zip files and like all kinds of different regions, so that all of the computing that Sam does is done for you ahead of time. I'm not going to do that because you would have to deploy these Lambda functions in every single region, make them publicly available, all that. And this is just, I think, a cleaner way of doing it. Okay, so now it is initiating deployment. It's going to ask me to change sets. This time I don't have a typo in my YAML file. I really hope. Yes. And again, see, look, it took this one resource block of YouTube download, and in the cloud in AWS is going to create two resources, the function and the role, which is specified by these policies. So this shorthand is really useful. Okay, it's creating. So it got past the first step. Okay, so I'm going to get ready for this. So here's my function. It'll be soon deployed up in AWS. What am I expecting as the input? Input YouTube video name and YouTube URL. So I need to create, sweet. So now if I come over to resources, there should be a new resource called YouTube download, which is my hastily written node code. Awesome. And what I can do is I can just invoke it directly. So let me just do that. So I expect two inputs, YouTube video name. I meant to put it as the key. And YouTube URL. So looking at this one, this is my YouTube URL. And then the name. How did it specify it over here? It just did hyphens for everything, right? I just want to match. Cool. So when I am getting ready to, let me just, yeah, okay. This should be the correct input. So now let's see what happens. Test this. If this works, I'm going to be extremely shocked. Promise.resolve. So here I'm just going to, are you kidding? Node.js promise resolve. I feel like I've done this many times. So promise.resolve. What I want to do is I want to create a new promise. Node.js promise constructor. Oh, that's... Oh, man. I knew this. Coding always makes you humble, doesn't it? I don't know why I'm modifying it here because I'm probably going to throw away all this. Okay, so this is what I was talking about. So I made changes in my local, but then I can also just come up to the cloud and say, you know what, there's my new code. Deploy it, and let's just test it. If you do this too much, then you can get out of sync with your local machine, and that's not good. So let's deploy this and see what happens. Unhandled promise rejection. That looks better. Command failed with exit 127. No such file or directory. No such file or directory. Huh. All right. Nice thing is it did package up all my dependencies correctly, so that's nice. So let's go to YouTube DL. This is what I get for just trying to copy and paste code from a blog. An old blog. I'm sure the blog worked great at one point in time. Var runtime. You know what? I know what the issue is. The issue is it can't find... It doesn't matter what the issue is. This doesn't work. I don't like the library. The library's been... again, this is hats off to this author. Great job. This is just a blog post written 2 years ago. It's using a library that's since been deprecated and isn't working anymore. So that's totally fine. I just need to figure out a new way to do this, and I will do that before Friday, and we will work on that. So let me check this in, though. Git status, add. I'm checking in the YouTube download, even though I'm going to rewrite it, but I want to make sure that people can look at everything that I'm writing and see the history and all that. Finished the media convert functions, started YouTube downloader. Okay. I checked in all the node modules. Can I just do a git remove? Oh my goodness. I should rebase and merge and blah, 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 but I cannot type today. Let me just make sure that up here. I don't like that my GitHub now has all that in there, and maybe I'll go back. It doesn't matter. Doesn't matter. I deleted it, all the no modules, but it's in history. Yay. Anyway, thanks for following along. I'll get working on that. I'll do my homework. I'll make sure that I'm ready for Friday. We will get downloading YouTube videos. I'll also figure out how to get the trigger going from YouTube. So I'm going to figure out those two things. And what I'm hoping is, my goal is by next Tuesday when we do office hours, by the end of that, I will get a trigger and my infrastructure will run so that we can look at that on Wednesday and say, wow, we have at least the transcripts and comprehension done, but not uploaded to a database. And I think that'd be too much to get done all by Mondays to have everything uploaded in the database, but maybe not. We have 2 more days of live streaming. So Thanks. Hope you had a good insight into how my brain works, and maybe hopefully this inspires you to go build something with Alexa too, or at least these services, or at least have fun. And I think that's one of the end goals. So with that, I really want to thank everybody, and I will see you guys next time. Thanks again.